surface, and the frictional force is equals to 9 newtons. And we are told that the coefficient of the kinetic friction between the 4 kg block and the surface is equals to 0.2. So both of these blocks are connected by a rope with tension T. And this rope is frictionless. And we are not in the direction of this whole system. So we're going to make an assumption. And our assumption will be that this system is going in that direction. So the first question says, draw a free body diagram showing all the forces acting on the 10 kg block and the 4 kg block. So one of the important things to note is the 10 kg block, it's sitting on a flat surface, and it's going to have a normal force in, and it's going to have the weight, which will be equal to the normal force, and you're going to have the tension, and you're going to have the frictional force, if. This is for the 10 kg block. And then for the 4 kg block, it's important to note that it's sitting on a slope that makes an angle of 30 degrees. So we're going to have a normal force, which will be perpendicular to the slope. And you're going to have the weight, which is straight down. And we're going to have the tension and the frictional force, like so. Alternatively, you can draw the 4 kg block showing the component of the weights as W perpendicular and W parallel to the surface. So you're going to have W perpendicular, and you're going to have W parallel, and you're going to have the tension and the frictional force. So both of these are correct, but it's not correct to show the weights and show its components in one diagram. That would be wrong. This would be wrong. So either of these two components, so it's either you show the weights or you show its component as the perpendicular or the parallel components. So we move on to the second question, which says calculate the magnitude of the frictional force between the 4 kg block and the surface of the inclined plane. So we are given the coefficient of the kinetic friction, which is 0.2 on the 4 kg block. And we're going to make use of the formula which says Fk is equal to mu k multiplied by the normal force. So for the 4 kg block, the normal force is equal to the perpendicular component of the weight, which the perpendicular component is equals to mg cos theta. So the W parallel is equal to mg sine theta, and the perpendicular component is equal to mg cos theta. There's a whole mathematical reasoning towards this, but it's important to remember these formulas because they're not given in exams. So it's going to be 0.2 multiplied by 4 multiplied by 9.8 times cos of 30, which is equals to 0.2 times 9.8 times 4 times cos of 30. It's equal to 6.79 newtons. Then the second question says, we need to calculate we have to calculate the acceleration of the whole system. So to calculate the acceleration of this whole system, it's important to note that the 4 kg and the 10 kg block, they both have similar tension, and they both going to experience the same acceleration since they are connected by one rope or one pulley. So the approach to this question is to utilize Newton's second law, which says F net is equal to ma, and you're going to treat each block independently. So for the 10 kg block, the only forces that are acting in the motion of the system, it's the tension and the frictional force. So we're going to use Newton's second law. F net is equal to F pulley, and tension minus the frictional force is equal to MA. And the tension is given to us as 9, and the mass is 10 times the acceleration. And if we make T the subject of the formula, we're going to have T equals to 10A plus 9. This would be our first equation. And then for the 4 kg block, we have 3 forces that are acting in the direction or in the axis of motion. So we have the W parallel minus the tension minus the frictional force, which is calculated. So our F nets will be equal to W parallel minus the tension minus the frictional force equals to MA. So W parallel is equal to mg sine theta minus T minus FF is equals to MA. So we're going to plug in our values. 4 multiplied by 9.8 sine 30 minus T minus 6.79 that we just calculated is equal to 4A. 4 multiplied by 9.8 multiplied by sine 30 minus 6.79. That gives us 12.81 minus T equals to 4A. So now we have 2 equations, and we're going to solve simultaneously, plugging equation 1 into equation 2. And you're going to have 12.81 minus 10A plus 9 equals to 4A. And you're going to solve for A. So this will give us 12.81 minus 10A minus 9 equals to 4A. And 12.81 minus 9, that is 3.81. And you're going to transpose this 10A to the other side. Is going to be 10 plus 4A is going to be 14A. Therefore, A is equals to 3.81 divided by 14. A is equals to A is equal to 0.27 meters per second squared. Then we move to the last question, which says calculate the tension in the string. So this is very simple. You're going to just take equation 1 and put the value of A that we just calculated. So equation 1 is 10A plus 9. Then you're going to put 0.27 plus 9. This would give us 11.72 newtons.